Angle between two planes in Cartesian form. In this module, you will learn about the angle between two planes in Cartesian form. Let us recall the equation of a plane in normal form in vector form. Let D be the perpendicular distance from the origin to the plane. Let vector R be the position vector of the point P. Then, equation of a plane is given by vector R dot vector N equals D, where vector N is the normal to the given plane. In Cartesian form, the equation of the plane is given by capital AX plus capital BY plus capital CZ plus capital D equals 0. Here, capital A, capital B and capital C are the direction ratios of the normal to the plane. The angle between two planes is defined as the angle between their normals. For the sake of convenience, we shall consider the acute angle between the planes. Let capital P1 and capital P2 be two planes with equations vector R dot vector N1 equals D1 and vector R dot vector N2 equals D2. Here, vector N1 and vector N2 are normals to the two plane. Let theta be the angle between the two planes. Then, the angle between the two planes is given by cos theta equals mod of vector N1 dot vector N2 by mod of vector N1 into vector N2. Two planes capital P1 and capital P2 with equations vector R dot vector N1 equals D1 and vector R dot vector N2 equals D2 are perpendicular if vector N1 dot vector N2 equals 0. Two planes capital P1 and capital P2 with equations vector R dot vector N1 equals D1 and vector R dot vector N2 equals D2 are parallel if vector N1 is parallel to vector N2. That is, vector N1 equals lambda vector N2. In Cartesian form, the equations of the planes are given by P1 represents A1x plus B1y plus C1z equals D1 and capital P2 represents A2x plus B2y plus C2z equals D2. Here, capital A1, capital B1 and capital C1 are the direction ratios of the normal to the plane. Here, capital A2, capital B2 and capital C2 are the direction ratios of the normal to the plane. The angle between the two planes is given by cos theta equals capital A1, capital A2 plus capital B1, capital B2 plus capital C1, capital C2 by square root of capital A1 square plus capital B1 square plus capital C1 square into square root of capital A2 square plus capital B2 square plus capital C2 square. Capital P1 represents A1x plus B1y plus C1z equals D1 and capital P2 represents A2x plus B2y plus C2z equals D2. Two planes capital P1 and capital P2 are perpendicular if capital A1, capital A2 plus capital B1, capital B2 plus capital C1, capital C2 equals 0. Two planes capital P1 and capital P2 are parallel if capital A1 by capital A2 equals capital B1 by capital B2 equals capital C1 by capital C2. Let us see an example. Find the angle between the planes 2x minus y plus z equals 2 and x plus y plus 2z equals 3. Solution. Let capital P1 represent plane 2x minus y plus z equals 2 and capital P2 represent plane x plus y plus 2z equals 3. The direction ratios of the normal to the plane capital P1 are capital A1 equals 2, capital B1 equals minus 1 and capital C1 equals 1. The direction ratios of the normal to the plane capital P2 are capital A2 equals 1, capital B2 equals 1 and capital C2 equals 2. Mod of vector n1 is given by square root of capital A1 square plus capital B1 square plus capital C1 square equals to square root of 2 square plus minus 1 square plus 1 square. This results in square root of 6. The mod of vector n2 is given by the square root of capital A2 square plus capital B2 square plus capital C2 square equals to square root of 1 square plus 1 square plus 2 square. This results in square root of 6. Vector n1 dot vector n2 equals 3. This implies that cos theta equals 3 by 6 and this equals 1 by 2. This implies that theta equals cos inverse of 1 by 2. The angle theta between the two planes is given by pi by 3. In this module, you have learnt about the angle between two planes in Cartesian form. The angle between the two planes is given by cos theta equals capital A1, capital A2 plus capital B1, capital B2 plus capital C1. Capital C2 by square root of capital A1 square plus capital B1 square plus capital C1 square into square root of capital A2 square plus capital B2 square plus capital C2 square. Two planes capital P1 and capital P2 are perpendicular if A1 capital A2 plus capital B1 capital B2 plus capital C1 capital C2 equals 0. Two planes capital P1 and capital P2 are parallel if capital A1 by capital A2 equals capital B1 by capital B2 equals capital C1 by capital C2.